Welcome to the training module on 6800 series AC power source with built-in AC power analyzer. This training module will introduce 6800 series AC power source analyzers for generation and measurement. These one-box solutions have generation, measurement and AC power analysis capabilities. Agilent's AC power sources are ideal for power supply testing, AC mains CE mark testing, UPS testing and much more. Choose from 375 VA, which is 6811B, the 750 VA, which is 6812B, or a 1750 VA, which is the 6813B AC power source, with built-in AC power analyzer. Setup is made easy with the graphical user interface, which requires no programming. The Agilent 6811B provides a complete AC and DC power and measurement solution with extensive features to predict valuable DUTs. The AC source combines three instruments in one unit, as shown in the following figure. The function generator provides waveforms with programmable amplitude, frequency and shape. The power amplifier amplifies the function generator signal to produce the AC power for your application. The measurement functions range from a simple readback of RMS voltage and current to sophisticated capabilities such as waveform analysis. This page lists the specifications of the AC source. Performance specifications are warranted over the ambient temperature range of 0 to 40 degrees C, unless otherwise noted. Specifications are for a sine wave with a resistive load at an output frequency range of 45 Hz to 1 kHz, in AC coupled mode after a 30-minute warm-up. The 6800 series provides control of many output parameters. Most of these can be programmed as an output transient. Upon receipt of a trigger, an output parameter set to step, pulse or list mode will transition from an intermediate level to one or more levels. The number of successive output settings is, in part, what differentiates one transient mode from another. The AC source steady-state output characteristic is shown in this page. Steady-state characteristics are defined as those output ratings that will be maintained by the AC source for an indefinite time. The figure shows both the AC and DC characteristics. With programmable output coupling, the AC source can couple DC as well as AC output voltages. This page shows the setup for the tests. Care has to be taken to use load leads of sufficient wire gauge to carry the full output current. When performing the verification tests, the GPIB controller, you may have to consider the relatively slow settling times and slew rates of the AC source as compared to computer and system voltmeters. Suitable wait statements can be inserted into the test program to give the AC source time to respond to the test commands. Programmable output of the AC power source or analyzer can operate in one of four modes: fixed, step, pulse or list. The default setting is fixed mode, where the output will stay fixed at a program value until another command is sent to change it. The remaining three operating modes constitute the transient subsystem. Output transients are used to synchronize output changes with a particular phase of the voltage waveform, synchronize output changes with trigger signals, stimulate AC line disturbances with precise duration and phase control, and create sequences of output changes. The 6800 series can help you test and improve your products. It helps in measuring current harmonic content and creating custom AC power waveforms, such as the combined AC plus DC signal to stimulate a telephone ring, or measuring current harmonics, voltage fluctuations and flicker emissions, and generating voltage and frequency disturbances and interharmonics to determine product immunity. In addition to overcurrent, overvoltage, overpower and overtemperature protection, the 6800 series offers output disconnect relays and remote inhibit capability, quickly disabling the output of the AC source via a TTL signal to protect the device under test. Triggers can be used to change the output, synchronize a change to a phase of the waveform cycle, and synchronize a measurement to an output change. The effectiveness of the triggering capability can be shown when measuring worst-case inrush current of a switching power supply. Using the 6800 series triggering subsystem, the output can be triggered to turn on at a phase near the peak of the AC cycle for stimulating a worst-case AC-like condition. Simultaneously, the AC source can be triggered to take current measurements to characterize the behavior of the power supply under test. In addition, triggering can be extended to external test equipment via the trigger out connection. The Agilent AC source GUI makes it quick and easy to set the output of your Agilent AC source, be it from a stored waveform or with a waveform that you create using your mouse. The GUI also allows you to see the output of the AC source in graphical form, save the results, or dump them directly into a Microsoft Excel file, or to access with the raw data often helps in understanding the test results. The Direct Excel link feature makes it easy to keep the results of many tests and makes them easily retrievable. With it, the test records resulting from changing conditions can be kept in one place and easily compared. Some applications, such as the simulation of European railway power systems, a low-frequency 16.6 Hz AC waveform is required. Generating low-frequency waveforms with AC sources can present testing challenges due to output power derating and programming inaccuracies, depending on the regulation technique used. If the AC source has measurement capability, control of the measurement sample period is necessary to capture sufficient cycles of the output waveform to ensure measurement accuracy. The 6812A and 6813A can meet the above challenges at frequencies below 45 Hz. These two models provide precise control of the waveform generation and measurement control system for optimal operation at low frequencies. The Agilent 6811, 12 and 13B is ideal for applications such as power supply testing, UPS testing, avionics ATE, and for the testing of power factor corrected equipment and devices. Save space on a lab bench or in a test rack with this flexible instrument, which can take the place of an AC source, DC source, and acts as a powerful arbitrary waveform generator, as well as a sophisticated power analyzer. An optional second power analyzer is available, which can be used independently from the source or for dual node measurements such as power supply input-output efficiency tests